Welcome to Build Wealth Logically. Your path to financial growth starts here. Calculate, invest, and grow.
All right, let's dive right into this. We're going to explore a really fascinating contradiction that's happening right at the heart of Kenya's economy. It's a story about a major crisis that, believe it or not, is also a massive opportunity in disguise.
76%. Now on the surface, this number looks pretty good, right? It looks like a success story. This is Kenya's official electricity access rate. And it sounds respectable, like real progress is being made.
And when you stack it up against other major economies on the continent, it still seems pretty solid. I mean, it's not at the very top, but Kenya is right there in the mix with places like Ghana and South Africa. So the official story is one of progress. But that number, it doesn't tell you the whole story, not even close.
And that brings us to the core idea of this whole explainer, what we're calling the Kenyan power paradox. It's this huge glaring disconnect between what the numbers say on a spreadsheet and what's actually happening on the ground, on the factory floor.
Because here's the reality. While the official access rate is 76%, manufacturers in Kenya lost 340 hours of production just last year, all due to blackouts. Think about that. That's 14 full days, 2 entire weeks of work gone. We're talking dead assembly lines, idle workers, spoiled products. All of a sudden, that 76% doesn't feel so great, does it?
So, what is going on here? To really get this paradox, we have to look past those shiny headline numbers and dig into the data that shows us where the real infrastructure problem is hiding. And here is our first big clue: 24.2%. So what is this? This is the amount of electricity that gets generated in Kenya but never actually makes it to the customer. It just vanishes, lost in transit.
And this number is just staggering when you see it in context. Losing nearly a quarter of all the power you generate from the grid is incredibly inefficient. Just compare that to Ghana or South Africa. They lose about 10 or 11%. And a super developed grid like Germany's? They only lose 4%. Kenya is literally just burning money before it even gets a chance to power anything.
And this right here, this is the killer metric. It's the annual electricity consumption per person. At just 189 kilowatt hours, Kenya's consumption is just a tiny fraction of its peers. There's just no way you can run a modern industrial economy on that little power. This isn't just about energy. It's a fundamental problem with the infrastructure design itself.
And here is the ultimate paradox, the thing that's just wild. Kenya is actually a leader in green energy. 78% of its electricity comes from renewables like geothermal and wind. And yet, because that green power can't be delivered reliably, manufacturers are forced to pay an absolute fortune. We're talking 35 cents per kilowatt hour for dirty, expensive diesel generators just to keep the lights on.
But this unreliable grid creates another crisis. It's a deeper one that a lot of people miss. It's this hidden automation gap, and it's holding back the entire manufacturing sector. Okay, so this number, 4.5, what does this mean? This represents the density of what are called programmable logic controllers, or PLCs, for every 1,000 industrial workers in Kenya. And PLCs are basically the industrial computers, the brains that automate a factory.
And when you see how that stacks up globally, wow. With a density of just 4.5, Kenya isn't just energy poor, it is automation starved. It's light years behind industrial powerhouses like Germany, and it's even way behind regional competitors like South Africa.
And look, this is not just some abstract statistic. This is the reality on the ground. This quote just nails the problem. A lot of these factories are running on ancient technology from the 1990s. We're talking about hardware that has been obsolete for decades. Stuff that nobody locally even knows how to program or fix anymore.
And this creates this awful, vicious cycle of dependency. A foreign company comes in, they install the system, and then they leave. The local engineers, they don't get trained to maintain it. So when something inevitably breaks, the factory has to wait for days for a technician to fly in from somewhere else, and then they have to pay for it in expensive foreign currency. It's a system that's literally designed for dependency, not for resilience.
So, okay, if that model is totally broken, what's the alternative? Well, the answer isn't a bigger grid or taking on more foreign loans. The answer is a new, localized solution that's actually designed for the realities on the ground in Africa.
It's called the VoltVault Architecture, and it's built on 3 integrated layers. First, local power generation. Think solar and batteries, sized specifically for what a factory actually needs. Second, a smart AI-powered microgrid that manages that power seamlessly, so when the national grid flickers, the factory doesn't even notice. And third, and this part is crucial, open automation systems using modern, open-source hardware that can be programmed by local Kenyan engineers.
And when you look at the money, the economics are just a no-brainer. The old model, relying on the grid plus that expensive diesel backup, costs about 28 cents per kilowatt hour. The Volt model can deliver far more reliable power for just 12 cents. That is less than half the cost. So the benefits here are just huge. You go from 76% grid reliability to 99.5%. The system pays for itself in just 4 to 6 years, and it'll last for 25. But here's the most important piece. This model isn't just about installing equipment. It's about building up local skills and capacity for the long term. So really what we're talking about here is a fundamental shift in thinking. It's about moving away from that old broken model of dependency and embracing a new model built on local resilience.
Now, let's be totally clear. This is not a magic wand. These microgrids need maintenance. Batteries degrade. The skills gap is real, and it's going to take years to close. There are going to be failures along the way, but every single one of them is a chance to learn.
And that, right there, that is the true meaning of resilience. It is not about building some perfect system that never fails. It's about building the local capacity, the local muscle, to prepare, to recover, and ultimately to grow stronger from any disruption.
So the takeaway is this: the data tells a really clear story. Waiting around for the national grid to solve these problems, that's not a viable strategy. The only real path forward is to build local capacity with solutions that are designed for local realities.
So I'll just leave you with this one question to think about. What if the future of infrastructure in places like Kenya isn't about building bigger, more centralized systems? What if it's about fostering thousands of smaller, smarter, and truly resilient local ones?
If you believe wealth should be engineered, not guessed, like this video, subscribe, and hit the notification bell so you never miss the next strategy.